The second part of Module 6, Lesson 1 deals with a cell phone bill, and we're going to do 5 different scenarios on this cell phone bill. So the two things you're going to need, if you have them, are a straight edge, because we're going to be drawing 5 different lines, 5 different graphs on the same coordinate plane. And if you have 5 different colored pins or colored pencils, that would be good too. That way you can see the different lines and they won't all be the same color, and it ends up being a really pretty picture at the end too when you use different colors. I'm kind of a color fanatic, but my students always tell me in Math 126 that it is so helpful to have stuff color coded. So if you have 5 different colored pens or pencils, that would be great. Okay, so this is Module 6, Lesson 1, Student Page C, Page 1. It's the 5th page of the packet. So on the videos, I just called it Page 5 because it's the 5th page of the packet, because I didn't want to write all that stuff. Module 6, Lesson 1, Student Page C, Page 1. So it's the 5th page of the packet. So we are going to start with the first scenario. Multicellular charges $6 per month, and we're experts now at writing equations, right? So their charge is $6 per month plus 10 cents per minute. So you should all be able to write an equation for that right now. So let's go down here and do it right above this. So charges, so should we call C the charge? $6 per month. So how about we call, and this is just a monthly cell phone bill, so this actually is extra information because we're just talking about a 1-month bill. So you don't have to write 6M, you'll just write 6 plus, and then it says 10 cents per minute. So the cell phone charges, let me see if I can put this up. No. Yeah, I'm trying to adjust the light on this and it's just not getting very good. There we go. That's better. Because there were too many shadows before. So the charge is $6 per month plus 10 cents per minute. So C is the cell phone bill. And M is 10 cents per minute is number of minutes. And the cell phone bill obviously will be in dollars, but we should still write that. And M equals number of minutes. So now we have 2 really good variable statements there, stating what it is, what's the units, stating what it is, what's the units. And we can use this on the next page too when we're making the t-table. Okay, back up here. I like to kind of write down things as I go. That way it's not so overwhelming. So first sentence is done. Draw a horizontal axis representing the number of minutes talked and label it 0 to 100. So horizontal, think of horizon. So this is, okay, let me go back to the coordinate plane. So we're going to learn this in the next section, but this is called quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Most of the time when we do word problems, we're in quadrant 1. Why? Because if we're doing minutes and charge, or minutes and cell phone bill, aren't they going to be both positives? And that's usually how it is. Not always, but many times when we do word problems, they're positive numbers. So we're just going to be right here in quadrant 1, because minutes can only be positive, and the charge of the cell phone bill or the cost of the bill or the amount of the bill is positive as well. Okay, so what I'm going to do is I'm going to divide this, so this is one big quadrant 1. So we're just drawing the first quadrant here. So with your straight edge, set it on this first line, make a dot at 0, 0. And we're going to draw the x-axis, but only the positive x-axis. So that would be this line here. And in this problem, it says horizontal axis representing the number of minutes talked and label it 0 to 100. Oops, didn't finish doing it. Making each box count for 10 minutes. So horizontal axis, call it number of minutes, and axes always have to be labeled with what they represent. And then 0 to 100 going by tenths. So down here we're going to write number of minutes. Like I said, when you're doing word problems on a graph, you always have to have the X and Y axis labeled. And then it says go 0 to 100 counting by tenths. So 10 minutes, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so we have the first sentence done. We wrote our equation for that. We have the second sentence done. Next, draw a vertical axis. So with your straight edge, go up from 0, 0 and draw an arrow, because both the minutes and the cost could go on infinitely depending on how much you talk. So you can't just have it in there, because what if someone talks 700 minutes? So that's why we have to put arrows, and the more they talk, the higher the bill is. Again, that's why we have to put arrows. Okay, and this is the amount of your bill, which, okay, this one for number of minutes, we called that M. And the cost of the bill, we called it C. So here we write amount of bill. And the units for that, remember, we always need units, otherwise people don't know if you're pesos, dollars, yens. So we have to always label our units. This one's minutes, this one's dollars. Okay, so amount of your bill, and label it 0 to 20. And they didn't tell us to go by anything, so that means we have to go by ones. And yes, it's okay to go by tens on one axis and ones on the other. You just have to stay consistent on the axis you're on. Like I've had students see that they have to go to 300 and they go 50, 75, 100. No. If you're going by 25s, you can't go by 50 on the first one. So what's important is that each interval is the same on an axis. 10, 10, 10. So if you went 50, 75, 100, you went 50, 25, 25, 25, and that would be incorrect, and it would make your graph wrong as well. So that's what we mean by consistent. So 0 to 20, so zeros down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we're going to use this graph for 5 different graphs, so that's why I'm making it perfect, because it's going to have 5 different lines on it by the end. 15, 16, 17, 18, okay, did it say 20? Did I miss something? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I guess we got to draw one more in. I think I kind of remember doing that. I just teach 091 once a year. Like last spring I taught it, and then didn't teach it summer, didn't teach it in the fall, and then I come back, and sometimes I forget these little quirks like this. So 20 it is. Let's see. Since all of the amounts are positive here, you will only need quadrant 1. So this is quadrant 1. Give your graph a title. So my cell phone bill sounds like a good title to me. And so these are all the important parts that need to be on every graph. And I'm going to make this a tiny bit smaller because I'm tired of going up, down, up, down. I want to get both. Okay, there we go. Now we at least have it all in. So a title, the y-axis has to be labeled with what you're calling y. Then it has to be labeled with what y represents and the units. And then the x-axis likewise has to be labeled with the letter you're using in your equation and then with the words. Okay, so those are the parts of a word problem graph that need to be filled in. And the title, they usually ask for it if they want it. Not everybody does that, but if they ask for one, that counts as points. So make sure you do that step. Okay, I think we're ready to go. We got everything done in the first paragraph. Now we're down to the second paragraph. So we have, if you talk for 0 minutes, and this is why I wrote the equation, and I feel like they should tell us to write the equation at this point, but I guess they want you just to figure it out in your head. But since we've learned how to write equations in the last module, to me it makes sense. Yes. You know, have your equation there and ready. So if you talk for 0 minutes, how much is your bill? Well, this is minutes. So to show your work, you just say C equals 6 plus 0.10 times 0. And we know this is just going to go away. Anything times 0 is 0. So the cost would be $6. If you lost your cell phone, still have the bill going, but you didn't talk any minutes, you'd still have to pay the service charge of $6. Create an ordered pair using the number of minutes as a horizontal axis, so we know this is the X. So our ordered pair, oops, it's right here, never mind, is minutes, comma, cost. So how many minutes? 0. What was the cost? $6. And let's make sure we did everything they asked. Talk, how much is your bill? Create an order pair. Yes, your order pair will have this format. Plot your order pair above. So this first graph, I'm going to do it black. So 0, 6. So next, if you talk for 10 minutes, so take your cost equation, 6 plus 10 cents per minute. So if you talk for 10 minutes, it'll be 6 plus 10 cents times 10 minutes. Actually, I'm going to put that in parentheses since we have a decimal there. How much is your bill? Well, if you can do it in your head, 10 dimes is $1. So that means the cell phone bill is going to be $7. And then of course, always back up your work with the calculator just to make sure you don't make any errors, because this is a 5-part problem. It goes over the next 6 pages, so you kind of want to make sure each of the parts are correct. So 6 plus 0.10 times 10. There it is, $7. So 10 dimes is $1 plus 6. Create an order pair, and remember the order pair is minutes first because X always has to be first in your order pair. X comma Y alphabetical order. So the minutes are 10 and the cost is 7. And then it says plot it. So minutes are 10 and the cost is 7. And this one gets a little redundant because we have to do this 5 times with 5 different sets of numbers. So just warning you, I'll try to break it into 2 videos so you can take a break. So we'll do the first 3 pages in one video and then the next 3 in the next. So if you talk for 20 minutes, so same thing, C equals 6 plus 10 cents per minute times 20 minutes. So 20 dimes I know is $2. So this is going to be $8. But I can easily type it in the calculator. All I have to do is hit the up arrow and change that to 20. And there it is. It's $8. Write your order pair and plot it. So minutes, comma, total cost. And I always tell students, write this on your paper, highlight it if you're doing something paper, pencil, to remind you about the order. Order is important. Your points won't line up in a straight line if you don't get the order correct. So minutes is first, 20, cost is second, 8. Plot the point, 20 minutes, $8. Okay, and we're going to keep coming back here. So if you have this stapled, you might want to pull that paper out because we're going to draw 5 different graphs on this. So we have to keep answering it. So lay it right there so it's easy to access. So let's transfer our equation over so that we don't have to keep turning the page. So C equals 6 plus 10 minutes or 10 cents per minute. So if you talk for 30 minutes, same old, same old. So C equals 6 plus 10 cents times 30. 30 dimes is $3. So this would be $9. And just change your 20 to 30. Whoops, went too far. And we can verify that it is in fact $9. Create an order pair. Minutes, that's another thing we should bring over. Minutes, comma, cost, just to make sure our order pairs are consistent. Minutes, 30, cost, $9. And then we go back to the front page and we say 30 and $9. Okay, so now they want us to look at what we've had. How does the cost change with respect to the numbers talked? And this is easier if you look at it this way. So let's put our other one in. Oh, excuse me. Seems to be a common theme. I must be allergic to something in my office. So 06, 10 minutes is $7, 20 minutes is $8, 30 minutes is $9. So it's easier in table format to answer this next question. So it says, how does the cost change with respect to the number of minutes talked? So for every blank minutes, the cost does what by what? So according to the table, for every 10 minutes, see how all of these are going up by 10? So plus 10, plus 10, plus 10. So for every 10 minutes talked, the cost, and this means goes up or goes down, increases or decreases usually, either one, goes up, increases, goes down, decreases. So the cost goes up by $1, up by $1, and up by $1. And you'll notice that about lines. If these numbers are in order, then these numbers will also be in order and have a pattern. And that's because we're going to study in this chapter that lines have a constant rate of change. Up 10, up 10, up 10, up 10, up 1, up 1, up 1. So that's called a constant rate of change. And we'll learn that that's called the slope. So the cost increases or goes up, whichever your favorite phrase is, by $1. So for every 10 minutes talked, the cost goes up by $1. And we're going to learn later that is called the slope statement. So determine the cost if you were to talk 100 minutes. So 100 minutes would be C equals $6 plus 10 cents times 100. So hit your up arrow and change 30 into 100. 100. Love that feature about the calculator. 16. Create an order pair and plot it. So order pairs are minutes first, 100, comma, cost, 16. And go back to our graph. 100 would be all the way up to 16, which looks like right there. And so because we know lines have a constant rate of change or slope, we can actually plot the other points in between by going up 1 over 1, 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 up 1 over 1. And then you can continue from here as well. Up 1 over 1, up 1 over 1, up 1 over 1. So I know all those costs just because I know that a line has a constant rate of change, and 1, all the points have to line up, and 2, the slope, the rise over run must be the same all the way up. So rise 1, run 2, rise 1, run 2, rise 1, run 2. And that's one of the themes that we're going to study in this module, so we'll learn more about it, but this is just kind of discovery right now. So we can draw in our graph. So we will start on the y-axis and go right forever. Because like I said, they can talk an infinite number of minutes. I mean, we could figure out how many minutes are in a month and stop it there. But for graphing purposes, we just need to show that it doesn't stop there. It keeps on going. Okay. So we can follow this pattern here and say 40 goes with $10. 50, let's just go ahead and fill this out. 50, 60, 70, 80, 90, 100, and we know 100 from above is 16. And so this goes up by $1, so it'd be 11, 12, 13, 14, 15. So I'm not going to bore you with all the details and do each one of those in the equation, but after you get like 4 points like we have, you can see a pattern, and you can use the pattern because lines will always have a pattern. And let's see if we have everything. I'm not going to write all of them as order pairs either, but you can see when the t table, these are the x values, these are the y values, so 0 becomes x, y becomes 6, so you can see the pattern there. The x values are usually listed in the left column. I can't even think of one example where they're not in the left, so usually could also be always, but there may be an exception, so that's probably good language. And the y values are listed on the right column. In this scenario, we will list the number of minutes talked because it said that was on the x-axis on our other page. So not only do you have to know it's the x values, you have to write what it is above. So the x values are number of minutes, and the y value is the total cost of the bill. So we completed the table. So next, complete the empty rows of the table. We did it. Be sure to list order pairs. plot all the points in the graph, did it, label this graph as original. So right here, I'm going to write original. It's like I said, we are going to have 5 graphs, hopefully all different colors, so we can see how they change. Okay, so there's the second page done. Oops, one more question. I almost missed that. Well, I was turning it too fast, wasn't I? So we did that. What is the meaning of the order pair 20, 8 from the table above? Well, the first thing I do is above the X value, I write minutes. And above the Y value, I write a $sign. And then it's very easy. Remember when we were doing word problems in the last module and I said the minute you get them labeled, write a sentence is so easy. So when the person talks 20 minutes, their bill will be $8. But I have students that don't take that extra second and label these and they say it backwards. So always look up at your table or look at your graph above the X, minutes, above the Y, cost. And so if a person talks 20 minutes, and that's a prepositional phrase, so that gets a comma after it, then their cell phone bill will be $8. And of course, you don't have to have my exact wording, but you have to include what 20 is and its units. You have to include what 8 represents and its units. So a cell phone bill will be $8 if a person talks 20 minutes. You could say that too, just as long as you have the 20 minutes and you have the cost of their bill. Okay. So that's the first 2 pages. So next we have variation 1, and I'm just going to do the first 2 on this video, and then on that, just because I want to do 3 pages and 3 pages so the videos don't get so long. And then I'll do the last 3 variations on the next video. Okay, so we're just going to do the very first variation. So now take a different colored pen or pencil. So now their cost per month increases from 6 to 10. So now it's 10 per month, but the cost of minutes stay the same, which on the last page it was 10 cents per minute. So now it's not $6 per month, now it's $10 per month. And the cost per minute stays the same. So again, we're getting ready to answer questions, so let's write our new equation. So C, the cost, is $10 plus, oops, I guess I didn't need to put units in there. I shouldn't do that. 10 cents per minute. So $10 plus 10 cents per minute. So determine the cost if you were to talk 20 minutes. So cost is $10 plus 10 cents for 20 minutes. And like we said before, 20 dimes is $2, so 10 plus 2. And you can do it on your calculator too. I'm just trying to save time so you guys don't have such a long video. So 20 minutes, $12. And then they're asking us to write an order pair again, so we should bring over that model so we don't mess up the order. Minutes, cost. And you don't have to write anything fancy, just a reminder of the order. So how many minutes? 20 minutes. What's the cost? $12. Create an order pair and plot plot it on the graph. Use a different color than you used before. So 20, 12. So $20, or excuse me, $20. Go, Kim. 20 minutes, $12. Okie dokie, so we got 9 done. You got to read these carefully because they have like a lot of buried steps in each one. So determine the cost, we did. Create an order pair, we did. Plot it on the graph, we did. Use a different color pen, we did. Okay, done. So now we have to complete the empty columns. So like I said, you really should have 3 or 4 before you start the pattern. So let's work out the first. We already know 20 is 12. So let's work out this one, and this one to establish the pattern. So when the cost is, or the cost will be $10 plus 10 cents times 0 minutes. So that becomes 0, so it's just going to be $10. And then next we have the cost at 10 minutes. So $10 plus, there's a lot of tens here. So 10 dimes is $1. $1 plus $10 is 11. And I think we can guess the next one, but let's just do one more just to be safe. 10 cents times 30 minutes. 30 dimes is $3. 10 plus 3, 13. So we've done enough now to establish a pattern. 10, 11, 12, 13, 14, 15. And remember, that means these have to be in order. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Because I've seen on a test before where students just assumed these were in order and filled this in and they got it wrong. So make sure these are in order first, which I didn't do, but I thought about it as I was in the middle. So since they're in order, we can do this in order. And what I always do, especially when I'm on a test, is figure out the last one, and then I can tell if I did the table right. Cost equals 10 cents, $10 plus 10 cents times 100. So let's just plug that one in real fast and verify that it is 20. So $10 plus 0.10 times 100 minutes. Ding, 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 ding. So that guarantees me that I have used my pattern correctly. So anytime I do a pattern like that, I always check the last one. On the last problem, we had already done this one, so we knew what it was, but this one we did it. So back to our graph, we're going to plot 0, 10, and 10, 11. So 0, 10, 10 is 11, and then one more, 30, 13. 30, 13. So again, we can see the pattern. So because we know lines have a continuous rate of change, we can use that slope to get the other points. Rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. Ooh, say that fast, real fast. Rise 1, run 1, rise 1, run 1. Still not saying it right. Rise 1, run 1. There we go. So let's go ahead and connect. And I've had students ask me in the past, why do you just put arrows on one end? Any of you thinking that same question? Well, this is number of minutes. If you continued the line over here, that would be in negative minutes. We can't have negative minutes. So our entire graph is only in the first quadrant, because going left of 0 would be going into the negative minutes. Okay, let's see if we've answered all these questions. Is this... Okay, getting mixed up here. Okay, wrong page. Put that page away, Kim. So it says complete the empty column in the table. We did. Be sure to list order pairs. We're not going to do that. Oh, we'll list one just for good measure, okay? Or maybe two. Just to show we know what we're doing. This is the X, this is the Y. Okay, so plot the points in the graph. Remember, okay, we did that. So now we're on the last question. Look at your new set of plotted points. Do your plotted points look different now that our monthly cost has increased from 6 to 10? Describe any similarities and differences. So I've done this a million times. So what the students and I have come up with, similar. There's one thing really big that's different, and there's one thing really big that's similar. So let's go back to the graph. Let's first talk about the difference. So where a graph crosses the y-axis, it's called the y-intercept. So the first graph has a y-intercept of 0, 6. The second graph has a y-intercept of 0, 10. So we would say the main differences in this one is the y-intercept increased or went up 4 when the cost increased by $4. So the y-intercept went up 4 units when the cost increased by $4. And what we're going to learn is the y-intercept is the starting point for every graph. And you can tell by looking what the y-intercept is. There's always going to be a number and a letter. That's going to be the slope. We're going to learn that in the next section. And the number alone is called the y-intercept. So I knew without even graphing this that the first point was going to be at 0, 6. And I knew without even graphing this that the first point on this is going to be 0, 10. So this one has a y-intercept of 0, 10. This one has a y-intercept of 0, 6. So that would be the main difference for the first part. The y-intercept, and then let's just remind ourselves what it is. It's the starting point, and it will always be the starting point of your graph in the first quadrant. So the y-intercept, which is considered the starting point, and y-intercept just means where it crosses the y-axis of the second graph is 4 units higher. And then we can state why, because it was a $4. And what did they call that? $4. What do you usually call that in a cell phone? Service charge? $4. Base fee? Base fee. How about that? Base fee. Higher. So the base fee on the cell phone plans, second one was $4 higher, therefore the y-intercept went up 4. Now let's talk about the similarities. Hopefully you see that one, they're parallel. And when two lines are parallel, we're going to learn that means their slopes are the same. So these two lines have the same slope, and slope is known as rate of change. 10 cents per minute, 10 cents per minute, 10 cents per minute, 10 cents per minute, because it's $1 for 10 minutes, but that's 10 cents per minute. So both lines have the same rate of change or steepness because their minute, sorry, per minute charge is the same. So both graphs have the same rate of change. And we're just practicing our vocabulary here so we're ready for the future sections. So both graphs have the same rate of change, which is slope, or you could also call it steepness. We don't really use steepness in math, but that makes students visualize what slope means. How steep is that mountain? How steep is that line? So both graphs have the same rate of change since the per minute charge for both is 10 cents per minute. I guess we don't have to say per minute again, right? So both graphs have the same rate of change, which is also called slope or steepness, since the per minute charge for both is 10 cents. So 10 cents per minute is called the slope of that line. It's going up 10 cents for every minute talked. 10 cents for every minute talked. 10 cents for every minute talked. So we can guess that when you change the base fee, the graph goes up or down, depending on whether you make it higher or lower. And that when you change the slope or steepness, if it goes up, the line's going to be steeper. If it goes down to 5 cents per minute, let's say, then the line's going to be flatter. So the per minute charge decides the steepness, and the base fee decides where it's going to cross the y-axis, because at 0 minutes it's going to be equal to the base fee. Okay, so that's it for the second video. One more to go for this section. I'll see you back then.